Hello everyone, I am Professor Sachin Mohangage from Sanjivani KVP Polytechnic, Kopargaon. Welcome all of you in Sanjivani Lecture Management System. In today's class, we are going to discuss the next content of Unit 2nd, that is corrosion, its prevention and electrochemistry. And the today's content for our lecture is electrochemical series or the activity series. So electrochemical series is nothing but the arrangement of the metal according to their oxidation potential value or either the reduction potential value. Here you see on the board all these are the metals and their potential values are given. So there are the electrode potential. We studied that electrode potential is nothing but the combination of the oxidation potential as well as the reduction potential. So here all these metals, they are arranged either on the basis of their oxidation potential value or either the reduction potential value. You see on the blackboard all these are the metals. Exception case only the hydrogen. Hydrogen is not a metal. So that's why the oxidation potential value as well as the reduction potential value for hydrogen is considered as a 0 volt, and therefore it is called as the reference electrode. All these are nothing but the electrodes. Okay. So the first one, potassium, and here the value is given minus 2.92. These values are the reduction potential value. Reduction potential value in volt. Okay. As you see that potassium, calcium, as we goes downward, it has been observed that when we go downward, the metal or the electrode becomes inactive. Okay. So here the reduction potential value, which is in a plus, for example for copper the reduction potential value is a plus 0.34, then your silver 0.80 and your mercury 0.85. This is a positive value for the inactive metal or the less active metal. For example, like your copper, silver and mercury indicate that this is the reduction potential values. Okay. So therefore you see that the reduction potential value of your potassium is minus 2.92. It is higher reduction potential value for the potassium. That indicate that potassium is highly active metal, and that potassium which are placed at the top of the activity series or the electrochemical series, that indicate that potassiums have a tendency to lose the electron. Okay. So reduction potential in the sense the tendency of that electrode to accept the electron, to gain the electron. But here, why the reduction potential value for potassium is very high and in a negative sign? Because the potassium is a active metal which are placed at the top of the activity, and that potassium metal have a tendency to lose the electron and not to accept the electrons. So therefore, when we write the oxidation potential value for the potassium, then it becomes plus. Just you have to reverse the sign of your reduction potential value. So negative sign becomes positive, and when it becomes negative, at that time we can say that when copper having a negative minus 0.34 value, then that value are said to be oxidation potential value. Okay, are you getting my point? Okay, now here the potassium having minus 2.92 volt reduction potential value, and so on. Calcium minus 2.87, then your sodium, magnesium, aluminum, zinc, ferrous, tin, lead minus 0.30. Hydrogen reference electrode, which is not a metal, non-metal, reference value is your 0, and then start your the less active metals. So these are the more active metal, and here these are the inactive or the less active metal. So here when we go downward to the upward, at that time the metal activity increases, but when we come from top to the bottom, at that time the metal activity decreases. Okay, so the metal or the electrode which are placed at the top are said to be a more active lose electron means it undergoes the oxidation reaction more preferably. So that is why this more active metal undergoes the corrosion. So according to the electrochemical series, the electrode or the metal which are placed at the top are act as an anode, while the metal or the electrode which are placed at the bottom of the activity series are said to be a cathode. Let's see the example. In case of your aluminium and say for example tin, which electrode is a cathode and which electrode is a anode in absence of battery. So here we are going to see the position of that electrode in a activity series or the electrochemical series. So which are placed higher in an activity series or electrochemical series are said to be anode. So here aluminium, the position is here, and for the tin here in comparison of aluminum and the tin is placed at the bottom of the activity series, and therefore they are said to be a cathode and aluminum are said to be a anode. Let's see the example of the tin and copper. Tin and copper. So here the copper is placed at the bottom of the activity series. So in comparison with this, the copper is placed at the bottom of the activity series, hence it is acted as a cathode, and no doubt your tin becomes anode. So when metal comes in contact with each other in presence of the conducting medium, at that time out of two, the one metal or the electrode act as anode on the basis of the position of that electrode in activity series, or according to the reduction potential value or oxidation potential value. At anode, the loss of electron, that is the oxidation reaction, take place, and therefore the anodic metal or the anodic electrode always undergoes the corrosion. Whereas at cathode, the gain of electron, that is the reduction reaction, take place. So at cathode, electrons are gained. So that is called as the gain of electron. That is called as the reduction, and hence it gets protected. So there is no need to remember the reduction potential values for all these electrodes. You have to just compare, or you have to remember that the copper, then your silver, platinum, gold, mercury, these are the inactive metal or the less active metal, as we already studied in the type of oxide film, where the unstable oxide film is formed on the inactive metals like your mercury or silver or the platinum or either the ores. So when we compare the aurum, silver, platinum, mercury, gold, etc. with the other metal or with the other electrode, then definitely we have to realize that these are the inactive metals, so they are act as a cathodes, whereas the above metal act as a anode. So here the conclusion is that simple. In an electrochemical series, we have to just remember that the more active metals have a tendency to lose the electron, so they undergo the oxidation, and they are act as the anodic metal or the anodic electrode. Whereas the electron or the metal which are placed at the bottom of the activity series have a tendency to accept the electrons, so it undergoes the reduction. So that's why the reduction potential values are higher, whereas the active metal which are placed at the top of the activity series have negative reduction potential value, so they have a tendency to accept the electron, and therefore it undergoes the reduction. So anodic metal due to the oxidation, it gets corroded, whereas the cathodic electrode or the metal accept the electron, undergoes the reduction process, and it will get protected all the time. This is all about the electrochemical series. Thank you.